Hey guys, we're going to take a look at some trig graphs and write the equations for them. We're going to fit either y equals a sine b quantity x minus h plus k, or y equals a cosine b quantity x minus h plus k. Now, I'll go through two examples. The first one here is in degrees. The second one I'll do is in radians. But before diving into it, there's a couple things you need to consider. If you're not told whether or not it's a sine function or a cosine function, if it's been inverted, if it's had a positive or negative phase shift, there's going to be lots of options for the equation that results. Because remember that these sine and cosine curves are infinite. There's no restriction on the domain. So you could see here, here's a negative cosine curve right there. And when we're writing the parameters in our equation over here, that a, b, and k value would be the same regardless of which iteration of the graph you're going to write. You could either start at this point of 20, or you could maybe start here, which we'll talk about where that is, and you could write the parameters for this part of the cosine curve. Again, it's inverted. But it has the same amplitude. The red and the blue have the same amplitude. They have the same period, and therefore same b value. And they also have the same vertical shift, if I didn't already say that. So the only difference is the starting point, or the h value, and whether it's going to be there or back here at 20. Now add to that no one's ever said it had to be a cosine curve, means this thing could be a sine curve. My horizontal axis is in between the max at 6 and the min at 2. That puts my horizontal axis at 4. And regardless of which sine or cosine graph you're going to write, you probably want to start with that horizontal axis. That's your k value. Because regardless of whether it's sine or cosine, that's going to be your shift. Now, if I want to do this as a sine graph, I could start, for example, right here and go up and come down and then finish right there. There's a positive sine curve. Now you see another one kind of left to the right there in red, not quite finished, but that would be another sine curve you could work on from there. Or, lastly, and then I'll get into actually writing it, you could start here and do a negative sine curve. I lied. One more. You could do a positive cosine curve in that silver one right there. So you have all these options for this graph. So while some students might choose sine, some students might choose cosine, some may go inverted or not. What's not going to change is the frequency, the vertical shift, and with frequency also is then the period, and lastly the amplitude. Those are all going to be the same. So A, B, and K, regardless of what you do, will be the same value. It's just, are you doing sine or cosine? I guess A could be positive or negative. I take that back. And then the H value. Where did you shift? So among all those things, we'll have to decide which one we want to do. And I'm going to leave that horizontal axis there at 4 and solve the rest of this problem in green. Now, given the information that I have, I'm probably, given the option, I'm probably going to go with a negative cosine curve. I know that this starting point here is at 20, and from there, I'm going to end right there. It looks as though I can fit two of these curves over the course of 20 to 160. So half of that would mean that's got to be 90 degrees. So this is 70 degrees, and that's 70 degrees. So my period is 70 degrees for this period of this cosine curve. So I'm just going to be looking at that guy ultimately. So if the period, which we know is equal to 360 degrees over b, and I know that my period is equal to 70 degrees, I can solve for b, and the b term ends up being 36 over 7. Not the prettiest number, but it's there. Now, I've determined that I'm going to start at 20. My b term is 36 over 7. I know my k term is 4, because I found that at the beginning. The horizontal axis has been shifted up. The last thing I need to find is my a term. And the a term is the amplitude, which is the distance from the horizontal axis to the max or to the min, which in this case is 2. So the amplitude is 2. But because I'm doing the inverted cosine graph, that means, let me move some of this stuff up there. There we go. That means that it's going to be a negative a term. So I've got all my pieces. I have a, which is equal to negative 2. I have b, which is 36 over 7. And I got that by taking the period and setting it equal to 70 degrees. I've shifted to the right 20 units, 20 degrees. That's my h value. And then my k value was the vertical shift, which was 4. So if I were going to write this out, I would have y equals negative 2 cosine 36 over 7 theta minus 20 degrees plus 4. And that would be my answer. But again, you could do this problem as a sine, a positive cosine, whatever you want. But the negative 2 could be a positive 2. This b term is going to be the same for all of them, and this 4 is going to be the same for all of them. It just will depend on how much you want to shift your graph and if it's positive or negative, sine or cosine. So that's the first example in terms of degrees.